The foundation for so many of the APIs that you use every day is Swift. It's fast, modern, and safe, guiding you toward code that's efficient, expressive, and correct. APIs allow you to take advantage of libraries and platform features and create experiences that are unique to your app. But some APIs can be hard to use, requiring you to write a lot of boilerplate code just to get started. That's why Swift is unlocking a new kind of API that's easier to use and easier to get right with the introduction of macros. And these macros are done the Swift way. A macro is an annotation that uses the structure of your code to generate new code that's built with your project. Macros can either be attached as attributes to your code, or they can be freestanding, spelled with the hash sign. Macros make APIs feel like they're part of the language, and there are so many ways to start using a new API with just an annotation. Macros come to life in Xcode, where the generated code feels like it's part of your project. Let me show you. I created a URL macro that checks for valid URL strings. Because macros generate regular Swift code, I can use the expand macro feature in Xcode to see exactly what they do. This macro looks really simple. It calls the URL initializer and force unwraps the result. But the URL macro does more than that. It checks that the string is a valid URL at compile time. For example, URLs can't have spaces, so if I add one, the macro provides a custom error message and a fixit to automatically remove the space from the string. This moves what would have been an error when my app is running into feedback while I'm writing my code, so I can fix mistakes right away. All macros have the ability to provide custom feedback to help you write correct code. Attached macros go even further, because they can add new functionality to code you already wrote. Let's take a look at what attached macros can do. I have a function called fetchContent that performs asynchronous work and uses completion handlers, but I want to use async await. Instead of implementing another fetchContent function, I can attach the addAsync macro. And that's it. Now, instead of passing in a completion handler when I call fetchContent, I can simply await the result. Just like any other API, I can use quick help on the macro to see its documentation. But if I want to understand how this works under the hood, I can set a breakpoint, run my code, step into the async function, and Xcode will expand the macro right in my source editor. This is really cool because there are no secrets. Stepping into an expanded macro while debugging is a natural way to peek behind the scenes and help me understand what's happening in my code. You can write your own macros, so you can extend the language in ways that were previously only possible by implementing features in the Swift compiler. Because Swift is developed in open source, developers are already using macros to build some of the most commonly requested language features, including automatically generating rich descriptions of assertion failures, providing customizable default protocol conformances, and the list continues to grow. You'll also see macros used throughout many of this year's new APIs. You can benefit from community-authored macros or share your own macros with others through Swift packages. Language advancements like macros enable Swift to be adopted in more projects than ever before. Let's talk about all of your code that isn't written in Swift. Since its inception, Swift has provided bidirectional interoperability with C and Objective-C. You can introduce Swift into your projects a single file or module at a time, without having to rewrite entire code bases. Swift is extending that interoperability to C++. Swift C++ interoperability allows you to use both languages in the same project without an intermediate bridging layer. You can share your classes, functions, and even template specializations like vector across both languages by setting a compiler flag. Using C++ from Swift will eliminate many sources of undefined behavior in your code, such as using variables before they're initialized. And bridging is efficient. Calls are made natively between your Swift and C++ code with minimal overhead. Swift C++ interoperability is already in use in open source, helping to transition the Swift compiler itself from C++ to Swift. And I am so excited to use Swift to implement Swift. Swift's fundamental goals of safe and expressive code are ingrained in the libraries that are built with it. And nowhere is that more apparent than with SwiftUI. Here's Josh to tell you more.